Hi everyone, this is the video on section 7.2 for geometry. We're dealing with areas of quadrilaterals. These are the other quadrilaterals, not rectangles or squares or parallelograms, but a little more complex ones, such as trapezoids, kites, rhombus, that kind of thing. So that's what this section is going to be all about. The first quadrilateral we want to work with is the trapezoid. Remember, a trapezoid has exactly one pair of parallel lines, and it can look a lot different, but it's still a trapezoid. Notice I drew this red diagonal here, and what I did was effectively divided my trapezoid into two triangles. So the height of each one of these triangles is the same. That's the distance between the two parallel sides. So my heights are the same. One of my triangles has one of these parallel bases as its base, and the other triangle has the other base of the trapezoid as its base. So what you can do to find the area of a trapezoid is put both triangles together at once. And here's the formula. So instead of 1/2 base times height, we have 1/2 times the height, which is the same for both, and then add the two bases together so that you're finding the area of both triangles at the same time. Just remember, those bases are those parallel sides. Let's walk through the process of finding the area of this trapezoid. Here's my formula: 1/2 times the height times the two bases added together. One base is 4.25 inches, the other is 3.25 inches, and our height is 6. So if I plug those in, I have 1/2 times 6 times these two bases added together, and 3.25 and 4.25 would be 7.5. So that's 3 times 7.5, or 22.5 square inches, and there's our area. Let's talk about a kite and how to find the area of a kite and why the formula for finding it actually works. If I took this kite and I cut along these dashed lines here that I've drawn, and I put this triangle and flipped it and put it here, it would look like that. And then took this triangle and put it here, it would look like this. And what you realize is we have, if I took these two pieces and moved them up here, we would have one rectangle that looks like this. And since a rectangle is just base times height, you realize that the area of this kite is this diagonal here and just this half of the other diagonal. So that's how we get the formula for the area of a kite. You take the two diagonals, you multiply the two diagonals, and it's just half of that because we're only using this half of the kite. So our formula for a kite is 1/2 diagonal 1 times diagonal 2. Remember, when you do these, when you multiply, you can multiply in any order. You can look at the numbers. Is it easier to take half of this diagonal and multiply it by all of this one? Or half, maybe you know this, half of this diagonal and multiply it by all of that? Or multiply this entire diagonal times this diagonal and multiply that by half. Any order you want will get the right answer. Here's the first example in our textbook for finding the area of a kite. Be very careful, watch your units, because they did this diagonal in centimeters and this diagonal in millimeters, and the units need to be the same. So you either need to change centimeters to millimeters, which means multiply both of those numbers by 10, or take your millimeters and change those to centimeters, which means dividing them by 10. So since this is 115 millimeters, that would be 11.5 centimeters. and then you can go accordingly. So if I have 1/2 diagonal 1 times diagonal 2, I think what I'll do is, since this is 11.5 and 11.5, I'll just half that diagonal. I'll do half of that diagonal is 11.5. I'm switching to centimeters. And I'm multiplying that by the entire other diagonal, which is 13 plus 30, or 43 centimeters. That will give me my area in square centimeters. So the answer when I'm all done is 494.5 square centimeters. Your number would be much bigger if you changed these to millimeters and decided to use millimeters. Either one is correct, so be sure, look at the problem and see if it specifies which units they want you to use. Our next figure is a rhombus, and what makes this so easy is that the formula for the rhombus is exactly the same as the formula for the kite, for the exact same reasons. If I cut this, I could put this piece here and it would end up being a rectangle. So it's basically base times height, except its height would only be half, just like the kite. So the formula is the same. The area is 1/2 of diagonal 1 times diagonal 2 in any order that you want. Okay, here's a rhombus, and we are asked to find the height of this rhombus. If this is 3 and this is 4, what would the height of our rhombus be? So what we're going to do is we're going to use the diagonals to find the area. And then remember that a rhombus is just a special parallelogram, which means its area is the base times the height. So once we find the area using the diagonals, then we can go back and use the formula for base times height to find the height. So when we use the diagonals, be careful, because this 3 only represents half of this diagonal, and this 4 only represents half of that one. So the area is 1/2 of 6 times 8. All right, 6 times 8 is 48, and half of that is 24. So our area is 24 square meters. Now we're going to use that area to find our height, because the area is also the base times the height. And our base happens to be 5. The height we don't know. So 5 times h equals 24. Now we know the area is 24. So in order to solve for height, we will divide by 5. And our height looks like 4.8. or 4 4/5 meters. What would you do if you were asked to find the area of a figure like this? This is a hexagon, and I haven't shown you how to find the area of a hexagon. We don't have a formula for the area of a hexagon. So what you can do is just break it up into smaller pieces that you can figure out the area for. For example, if I draw a line right through the middle of this hexagon, I will make 2 identical trapezoids. Now that I've drawn the line, now I know the formula for a trapezoid. It's 1/2 the height times the bases added together. So let's use the graph and these points to figure out the lengths of my bases and my height, and go ahead and find the area. So this base is 3. This base is 3. 1, 2, 3, 4, 5, 6, 7. This base is 7. This height is 4. And so is this height. So we have 2 identical trapezoids that have a height of 4 and with a base of 3 and a base of 7. So let's look at our formula. If you forget the formula for a trapezoid, just remember it's 2 triangles put together. So it's 1/2 base times height. It's just we have 2 bases. That's the only difference. So hopefully that will help you to remember. So we have 2 of these. The height of each one is 4. So we have 2 1/2 times 4 times 3 plus 7, or 10. So it looks like 2 times 1/2 is 1. Looks like the area of the whole thing should be 40 square units. That's what this hexagon would be. This next problem involves population density. Population density is how closely packed people are in one specific area. Let's say I overlaid this trapezoid over a map, and I know that about 15,000 people live in this small section of the city. This part of the trapezoid is 1.21 miles long. This is 0.38 miles long, and it's about a little over 1.5 miles high this way. So what we need to do for the population density is take the number of people divided by the square miles. That will give you the people per square mile. That's the population density. So we're told 15,000 people live here, and in order to find the square miles, we just need the area of this trapezoid. So here's all our numbers for finding the area of the trapezoid. Remember, it's 1/2 times the height, which is the distance between my two parallel sides. That's 1.52 times the two bases added together. One is 1.21, the other is 0.38. Add those together first, and then multiply times 0.5 and times 1.52. Use your calculator and see what the area is in square miles. So when you do that, and hopefully you actually do that, you get this is about 1.21 square miles. So a little over about 1.5 miles square. And you have 15,000 people in that area. So take 15,000 divided by 1.21, and that gives you how many people per square mile. And in this case, there are 12,397 people per square mile in this section of the city. Okay, it's your turn to practice. Here's a trapezoid, a labeled trapezoid. Go ahead and pause the video. Figure out what you think the area is, restart it, and see if you got it right. You should have put that the area is 1/2 times the height, which is 4, times the two bases added together, 8 plus 6, which is 14, and so that would be 28. 28, and the units are squared centimeters. Why did they give us this 4.5 for this side? Just to make sure you knew that you didn't need it. That's just something to ignore. Here's a rhombus. Go ahead and do it again. Here's the diagram. Here are the dimensions. What is the area? The first diagonal is 12. The second diagonal is 16. So the formula is 1/2 times 12 times 16. And these kind of things, what would be easiest for you to do in your head? For example, if I did 1/2 of 16, that's 8. And 8 times 12 I can do in my head. I know that. That is 96. And the units are square inches. You can do it any way that you want. You could go 6 times 16, or multiply 12 times 16, divide your answer in half, or divide your answer by 2. Either way, the answer should be 96. Here's a kite. How would you find the area of this kite? Do you remember the formula? And how are you going to find your values? Look at it, pause it and look at it, see if you can figure it out, and then come back and I'll show you what to do. Okay, the area of a kite is just like the area of a rhombus. It's 1/2 diagonal times diagonal. So I'm looking for the length from 0,4 to 6,4, and it's from 0 to 6. This diagonal is 6. The other diagonal is the distance from 3,6 down to 3, -1. My 3's don't change, but my y's go from 6 to -1. That diagonal is 7 units long, so this whole diagonal is 7. So it's 1/2 times 6 times 7. or 21, because it's half of 42. So 21, I don't know what the units are, 21 square units. This is high school geometry, so don't expect the problems to be simple. Oh, it's area, it's easy. You know they're going to complicate it as much as possible. You may be asked to use distance formula to find the lengths of sides. You may have some crazy figures to deal with. Do the best that you can, think it through, and I will see you guys in the next section.